Good afternoon. My topic this afternoon is plane areas. I will try to derive the formula for taking the area of a right triangle by using the horizontal slice. The last time around, I show you the solution of the derivation using the vertical slice. So for this afternoon, I will give you the solution using the horizontal slice. Okay guys, let's proceed. Our topic is 48 on my channel under my integral calculus topic, plane areas. Okay, I will read the problem. Derive the formula for taking the area of a right triangle with the base B, if the base is B, and the height is h using horizontal slice. Horizontal slice. Solution will be something like this. Try to figure out the right triangle on the Cartesian coordinate system on the x and y axis. Try to draw it. Okay, so in the formulation of the equation that will be needed in the solution, okay, you could visualize it. Y-axis, x-axis, this is the right triangle. Okay, this is the right angle. This point here should be 0, 0. This point here should be base in 0. The x here will be the base and the ordinate is 0. So this point here is base in 0. This point here should be the abscissa is B and the ordinate is h. Okay, this is B and this is h. So the coordinates of this point here is B and h. Let's draw the vertical slice. The vertical slice is this. Okay, this point on the vertical slice will be with the coordinates base in y. Okay, on this point here that lies on the hypotenuse, I will place the designation x and y. Okay, let us try to bring out the horizontal slice. It is this. The thickness is dy. It is vertically upward or downward, right? dy. And the length horizontally is xr minus xl. The length of this vertical slice is actually this length here minus this length here. The length over here is xr if we measure it horizontally, and the length here with reference to the vertical axis is xl, because actually this is xl and this is xr. Okay, so I place it there, xr minus xl. The length of the vertical slice. The vertical slice as it moves from 0 to h is variable. Okay, it's not a constant. It's not a rectangle. So it varies, you know. As it moves upward, it varies. That's why it's a variable thing. Therefore, I will repeat it. Differential area is xr minus xl times dy. Okay, let's bring out two right triangles. The first right triangle is the upper one. It is this. The bigger right triangle is actually the given right triangle. It is this. So actually, the bigger right triangle, the horizontal side is the given base, and the vertical side, the opposite side, the side opposite the hypotenuse, it is h, the given h. So actually, this is given, and this is given. For the smaller right triangle, it is this. I will cross-hatch it, this one. It is this. this side here should be h minus y. And this side here, okay, should be base minus x. Base minus x. Okay? Then, try to bring out the formula for taking slope. Taking the slope is actually m is equal to the tangent of this angle here, or the tangent of this slope. The tangent of this slope is opposite over adjacent. Opposite over adjacent. If this is m, this is also m. We are referring, this smaller right triangle was derived from the bigger right triangle. So if this is m, this should also m. Using the smaller right triangle, m is actually h minus y, the ratio h minus y over b minus x. Tangent of theta. Opposite over adjacent. And using the bigger right triangle, it is opposite over adjacent. It is h over b. If we try to simplify this, you remove this one now. We now have a resulting equation here. We now try to solve for x. Okay. We cross multiply. Okay. B minus x times h, it is this. The right hand side will be base times h minus y. Okay. Then dividing both sides by h. This h here cancel, or this will disappear. So b minus x will be b over h times the quantity x minus y. We try to solve for x. We are interested in the value of x. So if we add both sides of the equation by plus x, this is plus x. Okay? This will cancel out. We solve for x, right? So x now will be base minus the transpose value of this. That is b over h times the quantity h minus y. Okay? X is actually base, the given base, minus the given base over h times the quantity h minus y. But what is this x? This x here is the x of the hypotenuse, so I will place it here xl. I will now place the proper subscript. XL, I will just follow this one, but I will put the subscript. This is base minus base over h times the quantity h minus y, equation number 1. We need this one in solving for the area. And for a differential slice, differential area is actually xr minus xl times dy. The area of the differential area is the product of this times dy. This is xl. Okay. So what will come out? Differential area will be equal to, what is xr? xr is actually the equation of this one. The equation of this is xr is equal to b. That's a vertical line. It is just simply a vertical line. This, the hypotenuse, a little bit complicated because it was inclined, right? But for this one here, if we try to take the equation of this, okay, xr is equal to base. So this should be base minus open bracket, the complete value of xl as computed from equation number 1. So this is base minus base over h times the quantity h minus y, okay, times dy, right? Oh, it should be something like this, guys. Yeah, it should be times dy. The complete difference should be multiplied by dy. We are following this, okay? Therefore, this is now equal, differential area now will be equal to base. We now try to perform the negative sign inside. Minus open quantity b will be negative b, negative negative, this was plus b over h. B over h times the quantity h minus y times dy. So actually this base here cancel with this. So what will come out? differential area will be equal to base over h times the quantity h minus y times dy. Then try to take the integral of both sides now. This is now the integration portion. The integral of the differential area is equal to base is constant, h is constant, it will come out. So this will be base over h, the integral of the quantity h minus y times dy. And what will be the limit? For the horizontal slide, this dy here should move from 0 to h. So the lower limit is 0 and the upper limit is h. To cover the total area, okay, it should move from 0 to h. Okay, so this is 0 to h. This is now, we are now integrating. Base over h times the quantity, h is constant, okay, and the integral of h dy is equal to h times y. So this is h times y. The second one, the integral of y dy, it should be y squared over 2. Power formula. So the result after the integration will be y squared over 2. First one, it will be h times y. Second one will be y squared over 2 with the limit from 0 to h. Or substitute. Base over h. H times h will be h squared. H quantity square will be h squared over 2. That's the value of the thing. If we substitute the upper limit minus the value of this one here, if we place the value h equal to 0. H times 0 will be 0. 0 square will be 0. Okay? H times 0 is equal to 0. So this will be 0. H square, if we try to place the value of h to be 0, 0 square is equal to 0. And 0 over 2 is equal to 0. So this is still 0. So actually the value of the lower limit, if we place the value y equal to 0, this will disappear. Okay? Okay? So this is base over h. Okay? 2h square minus h square is h square all over 2. Okay? We cancel 1h over here. Only 1h will remain on top. Base times h is base times h. This is all over 2. So actually, the area for a right triangle is still 1/2 the product of base times height. It's the same. So by using the vertical slice and the horizontal slice, the resulting formula for taking the area of a right triangle is still 1/2 bh. Okay guys, that's it. Good afternoon, Los Angeles.